All right, so let's talk about multiplication when I am multiplying a whole number by a decimal. Okay, first thing we're going to talk about is the models and conceptually, what are we doing? What does this look like? So my first problem that I have is 3 times 500. Okay, remember when we read multiplication problems, we can read it as this is the same thing as 3 groups of 500. Okay, so let's picture what this would look like. I'm going to use 2 different colors today. So on my model, I need to make 3 groups of 500. So to make my first group, I'm going to count 1, 2, 3, 4, 5 and shade in 500. There's one group. Then I'm going to make another group of 500. So 1, 2, 3, 4, 5. I have 2 groups. And then I need one more group for 3 groups of 500. Then I need to count how many boxes in total, how many hundredths I have shaded in. So I have 5, 10, 15 hundredths. So 3 times 500 gives me 15 hundredths. Okay, when I look at my next problem, I have 4 times 11 hundredths. And remember, another way I can read this is 4 groups of 11 hundredths. And again, I'm going to use my 2 colors, and I need to create my first group of 11 hundredths. So that would be, there's 10, 11. So there's one group. There's 2 groups. There is 3 groups. And there is 4 groups of 11 hundredths. So in total, I have 1, 2, 3, 4. So that would be 40, 1, 2, 3, 4, 44 hundredths for my product. Okay, let's look at our next one. Our next problem, it says 6 times 2 tenths. So again, I can read this as 6 groups of 2 tenths. So let's use our colors. Let's make these pictures. So there is 1 tenth, 2 tenths, one group, 2 groups, 3 groups, 4 groups. And when I get to 5 groups, I've used an entire 100, which is okay. I just move on to the next one to make my last group of 6. Okay, so since I have this whole block shaded in, this whole block represents one whole, and I have 2 tenths of another whole. So 6 times 2 tenths gives me 1 and 2 tenths. For our very last model example, this time I'm going to zoom out a little bit. I have 4 times 6 tenths. So again, I can read this as 4 groups of 6 tenths. So let's use our colors. Let's draw this picture. So there is 1, 2, 3, 4, 5, 6. So there's one group. 1, 2, 3, 4, 5, 6. 2 groups. 1, 2, 3, 4, 5, 6. 3 groups. 1, 2, 3, 4, 5, 6. 4 groups. So I see that I have 1, 2 wholes and 4 tenths. So 4 times 6 tenths gives me 2 and 4 tenths. But again, like I tell my kids all the time, we're not going to draw models every single time we need to multiply. We also need to know the algorithm. What does this look like without pictures? So let's talk about our algorithm, okay? Now, the good news is we've been talking a lot about multiplication this week, and the process is still the same. So if I give us a problem like 14 and 6 tenths times, let's do 5, okay? I'm still wanting to put the number with the least amount of digits on the bottom. So my least amount of digits is 5. I'm going to put that on the bottom, and I am going to do 14 and 6/10 on the top. Now, when I multiply, what I want to do is I want to, and this is going to sound crazy, ignore the decimals. Don't pay any attention to them. So if the decimals aren't there, that number would look like the number 146. So when I ignore the decimals, it's also kind of like ignoring everything in your gut that tells you that your place value isn't lined up correctly, and that is okay. I don't care that my 5 is technically a 1s and it's not in the right spot, because again, I'm ignoring the decimal. I'm pretending it doesn't exist. Just like normal multiplication, I'm going to multiply the entire top row by the 1s place on the bottom number. So I have 5 times 6, which would give me 30. So I'm going to write the 0, carry the 3. I have 5 times 4, which would give me 20, plus 3 more for 23. So I'm going to write the 3, carry the 2. And then I have 1 times 5, which gives me 5, plus 2 more, which gives me 7. Okay, now we've got some other stuff on here we're going to ignore. I've completely multiplied everything. So my last step, since I ignored the decimal, is now I have to go place the decimal in the product, right? Because 14 and 6/10 times 5, for the number 730, that answer is way too big. So I've got to bring the decimal back into place. And here's how we do that. I need to count how many place value spots to move the decimal. So in 14 and 6/10, I have moved that decimal 1 place value spot. So in my answer and my product, I also need to move it 1 place value spot. So the product of 14 and 6/10 times 5 actually gives me 73 and 0/10. So I don't actually really need that 0. I can just call it 73.